Well, it appears that a couple of people didn't like the ASMR video I did on the failure of the 100 watt equivalent 17.5 watt LED lamp from Walmart. So I thought I would go back over it and show you what I found. So currently, as you can see, some of the LEDs are lit, and I am supplying about 18 volts AC into this unit at this time. Now, it's not very bright whatsoever, so that way it doesn't wash out the camera. But let me go ahead and shut it off, and I'll dial this up to about 120-ish volts. We'll plug it back in and power it on. Warning, bright lights. And you can see it's kind of a little bit of smoke. It's flickering. It's still very, very bright at this moment. There it goes. Now it's become much dimmer. So what I was showing you on the camera is this one LED is totally just burnt up. And so if I just measure the voltage across a given LED, I get 7.44 volts. Now if I measure the voltage across this LED, I get 92, 93 volts. Same thing down here. Measure the voltage, 7.1 volts, 7.1, but if I measure the voltage across this one, I get 99 volts. That is the problem on this half, and this one is the problem on this half. Now I did notice, when I had it zoomed in on the last video, like this LED only has two sections. So what is the voltage drop across it? Well, it's about the same, 7.1 volts, 7.1. So what are they doing differently? Because a couple of these I know are only two-section LEDs. I think this one might be, or it's failing, 7.1. Let me pause this and I'll zoom super close again and try to determine which ones are the triples and which one are the doubles. One moment. Okay, so looking back at these LEDs now, you can clearly see that these are all triples. And if you look at the width of the actual element, okay, stay focused, please. Let's put this in manual focus. If you look at the width of these, get rid of that hair, maybe. You can see these are kind of narrow compared to these, which are much longer. But there's only two of these, and they're not like staggered. Every one of these has three staggered LEDs. Of course, this one has a failure right there. That's the problem. So I'm so curious, why am I getting the same voltage? So I've got 7.17 on that one. It's a 2 LED light. And this one is 7.19. That's a 3. Maybe it's just because I'm not driving it very hard. Because honestly, I'm driving these things pretty doggone low. Oh, there's another 2 right there. Of course, you can't see the meter here. Now I've got 715. NorCal 715. What if I go to another triple? I get the same voltage. This is actually 716. And it appears that these are in series, which would be about right. That typically you see about a 3 volt drop per LED on a white, unless they're doing something different in these right here. Yeah, up to the, that one's getting ready to fail right there with the black spot right in the center of your screen. That one is just burnt the freak up. There's no getting around that one. It is toast. And I've got 94, 95 volts on that one. So somebody said, why don't you just put a jumper across there? Well, yeah, I could do that. No problem. But let me go ahead and zoom back out. And we may end up doing this and just using this as like a temporary backup. So let's get over here where you guys can see everything. Everything? Yes, everything. So what I did on the last video is with this 117 fluke voltmeter I have, if you put it in this position, it's low Z or low impedance. It actually puts a 3,000 ohm load across the terminals. So if I go across a working LED, it should actually go dark at this point. And it does. and I have 0 volt drop. But if I go across the defective LED, it's going to make the other ones light up like that. And as you can see, I still have a 60, well, I can't even see it, 61. See if I can block out some of the line. There we go. About 60, 61 volts on that one. And then about the same, 60 volts on that one. So I'm going to go ahead and we'll put this in milliamps. And I'm going to try to block some of the light here, and we'll see how many milliamps it says it's using. 72 milliamps. 72 milliamps. And down here, about the same, 72 milliamps is what these things are running. So I can either just put a jumper across it. As you saw in the other video, there's a circuit board in here. I don't think it's a switch mode power supply, but it does have a transformer on it. So I'm not sure. They might be using a boost converter, because we did have this up to, let's get these leads in the right holes. I think we had about 290 volts here. Yeah, 288, 9 volts. And so if they were just using a full wave bridge rectifier with filtering, you would see about 160 volts DC once it's filtered, rectified and filtered. So let's just go on the assumption that we're going to be seeing about 7.2 volts across the LEDs when they're working correctly, and about 70 milliamps. And I just want to see how much current these things are actually drawing, how many watts each one would be dissipating. One moment while I grab the phone and do some calculations. All right, so if I do some calculations here, if my voltage is going to be 7.2 volts and my current's going to be 0.07 volts, or 0.07 amps, or 70 milliamps, it's telling me that each LED is dissipating approximately 0.504 watts, or about a half a watt per LED. And if you count all of these LEDs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And I assume it's going to be 27 on the other side, because they're probably going to be balanced exactly. So what's that? 54. So 54 LEDs times 0.5 watts would be a total heat load of 27 watts. Yeah. So they're absolutely pushing these things to the extreme. There's not much of a heat sink, but I must say, let me grab the box. So I went ahead and bought the exact same ones. And so they claim non-dimmable, shadow resistant, lasts 18 years. Well, these things are probably only 2 years old. They do have a 3-year limited warranty. Return of defective product and receipt required for warranty claims. Duration of limited warranty based on average daily use of 3 hours. Limited warranty voided for misuse. How do you misuse it? Misuse the product per caution statement. So LED medium purpose, or general purpose medium base, use 17.5 watts, and then 1650 lumens, 5000K. I chose those because they're a nice bright white, but minimum starting, blah, blah, blah. So I wonder, I mean, I know this thing is less than 3 years old. If I just put it back together and take it back to Walmart, will they give me another one, I wonder? I know I have my receipt somewhere on my Walmart app. And FCC rules, blah, blah, blah. Daylight. Huh. Interesting. 120 volts, 17.5 watts, 5000K. Return the package and the receipt for replacement or money back. Now it says 3 years. I'm going to have to go through my Walmart receipt and see if I can find it. But you know what? It's neither here nor there. So yeah, a couple of people said just go ahead and remove that LED and just put a jumper across it, which we might actually do. and just see what's going to happen, because, so I'm curious, if I go back to milliamps, of course you won't be able to see it because my hand is going to be in the way. There we go. So if I move the voltage down ever so slightly, yeah, it's just, it looks like a linear regulator, because I'm turning the voltage down, the current's going down. Turn the voltage up, the current is going up. So all the way up is like 88 milliamps. So I think they're right. We'll just take one LED out of the circuit and see what is going to happen. All right, power off. See how long it takes to dim out. I'm sure there is still residual voltage there. We'll just go to DC volts. Only 3 volts. We'll go to low impedance. That will discharge it very, very quickly. Now the problem with getting these off is they're actually on an aluminum heatsink, which I've unsoldered. It just plugs in here. And it does actually have heatsink compound on the back of it. Actually, good job for doing that, because they certainly could have skimped. And then, as you saw in the other video, I did go ahead and pop that portion out. And you can see a big capacitor and a transformer. So I'm wondering what they are actually doing in there. Why would they would need a transformer? But like I said, they are, looks like they're using a boost converter to get more voltage out of the unit. And it does have a 33 microfarad 250 volt filter cap right there that I zoomed in on the previous video. So, well, I actually did find both of the screws that I took out, because the LED assembly is actually screwed down to this heatsink assembly with 2 screws. So they actually put a little bit of effort into this, just a little tiny bit, not too terribly much. So yeah, let's go ahead and get the soldering iron fired up and see if we can go ahead and maybe we can just solder a jumper and not actually take the LEDs off the board. That would probably be the easiest. So I'm going to try to leave it off of the heat sink, because that's going to help dissipate the heat by not having it heat sunk anymore. Now I could grab my LED, the LCD TV LED rework hot air station. Well, not hot air. It's just a hot plate. Basically, you set the LED strip on and it heats it up, and you can remove the LED much, much easier that way. Sorry, that was not in view there. And obviously it's not in focus because I had it on manual focus. Okay, well that's not much room to work with, that's for sure. So let me find some solder real quick, and we'll see if we can tin each side of it and just put a little jumper wire across it to bypass those LEDs. I doubt this is going to work. Stranger things have happened. Well, it looks like it's starting to take the solder. Of course, it's moving the solder to that one that I don't want. Now it's going to be tough. I don't know if it's worth saving a $3 LED light or not. I just don't know if it's worth it. Well, let's go the 12 volt vids way and just destroy it. Why not? It doesn't work anyhow. All right, finally something I can work with. I think this will just be easy, just to add a big old glob of solder across the whole thing. Maybe. Kind of like that. fixed. Like I said, if anything, I'm just going to use this like in my garage on a work light or something. And we'll try to destroy this one at the same time. I thought about actually putting a fixed resistor across it. Why? I think it's trying to lift off the board of all things. Yep, it lifted off the board. That's okay. Now the solder doesn't want a bridge. Why does it get a solder bridge when you don't want one? There we go. And then when you do want a solder bridge, you can't get one to save your life. I don't know. So I'm just going to loosely set that in there like that. Heatsink is off. And look at that. Come on, focus. All right, manual focus. So that's on basically very low power. And there's about 120 volts right there, working great. What's our current at the moment? No, not very much at all. Yeah, about 15 watts or so, but certainly bright enough to get the job done. Uh-oh, we lost another one on the other side. Which one did we lose now? No, this is not going to be a winning proposition, it looks like. I'm betting it's this one with the little dot in it. I should put the heatsink back on, I guess. One moment. Well, I got the heatsink back on it, turned it on, and it came back on again. Are you kidding me right now? All right, there's about 120 volts. There's 150. Trying to bring it up very low output to look and see if I see any of these that are out. And I don't. All right, I'm not going to use this thing. Let's take it apart. Why not, huh? So sometimes, let's see, let's get the center pin out of here first. It's just a pin that's pressed in. See if I can do it without stabbing myself. There we go, pin is out. And so there's just a single wire they just like push in there. Sometimes you can get lucky on these guys and you can put them in here and just do that. So there is the pin. So all I did is I basically just pulled sideways on this thing to get the board out. You know, take the socket out. You can always put the socket back on if you want to, just by pressing it back into place. Oh, sorry. You can always put the socket back on if you wanted to, just by putting it here and pressing it back into place. But this is the goal that I was looking for right here. So let's kind of zoom in on this if it'll stay focused. Put it back in auto. See how far I can push it. About that far. It's good enough. You can kind of see it there once it refocuses. Oh wow, are they doing power factor correction on this? Because that output capacitor goes right to the LED. And I think they've done this to have a better power factor, because there's no main filter cap after this first bridge rectifier. There's just these two little tiny, can you even see what the value is? No, they put them together. That's a 154, I don't know if you can see it or not. That's a 0.15, and then the other one is a 0.1. That's all the filtering that they're given this thing. So I'm thinking that they're using this as a way to get a better power factor. If I had to guess, I could be totally wrong on this. So there is a fusible resistor coming in. It does have an inductor. And then the 0.1 is across the output of the bridge rectifier. And then the 0.15 is after the inductor. So they're using that as a pi output filter network. And I'm wondering what that chip is. I'll have to try to look up some numbers on it. One moment, let me zoom in macro. Well, it appears it's going to be a BP3236. And then I think the rest of that stuff is all date codes and whatnot. K2D05VX, H1DN14C. Everything else doesn't look too terribly bad. There's some, there'll be a 680K discharge resistors in series to try to keep the afterglow at a minimum when you power this thing down. So yeah, it does look like they're using this like as a boost converter, if I had to guess. Might be wrong. There's the negative of the filter cap, and then the positive is right there, out of this diode and out of the transformer. Okay, I'm going to look up that chip and see what it does. I'm not going to big Clive and reverse engineer this, but I still want to know what this thing does, the BP3236. One moment. BP3236C, high efficiency triac dimmable LED driver. So there's some benefits of using this particular chip. There is a basic circuit diagram for this, and then some other options, operating temperature and whatnot, how they code them, which is exactly how this one's coded. And of all things, it does have a negative temperature coefficient thermistor on the board, and it is actually there, right there where it says NTC. So they are actually monitoring the circuit board temperature. And it does mention over here somehow as a buck boost converter, which I thought that's what they were doing. And I thought it mentioned it over here. Suitable for buck boost, or flyback LED lighting. Anyhow, there you go. So I'm going to grab a brand new one. I'll get the kilowatt. I want to see what the power factor is on this. It should actually be fairly decent. Okay, so there is a brand spanking new one for damp locations. You can use it in a damp location. That's good because I have it in my porch lights outside. Do not use with dimmers. And it is the exact same model, A21021, 17.5 watts, 0.145 amps, 5000 K, 1650 lumens. And I guess that's the manufacture date, possibly, something 23. No, that hasn't, 12/21/1, I don't know. Anyhow, I just bought these like 2 weeks ago. So, Hopefully this doesn't wash out the camera too much because I do have it screwed into the socket right there. Look at that. The power factor is 0.99. My eyes do not deceive me. 0.99. That is excellent. An ideal power factor is 1. No load. Power factor of 1. Here's another LED bulb. This is a crappy dollar store one. Power factor of 0.49. So we could certainly get into the differences between apparent power and real power. Here's another one. This is a GE LED, I believe. Yes, GE. I've had this for probably over 10 years. I used to use this because it's a 5000K. It was very hard to find 5000K LEDs years ago. And we got a power factor of 0.59. And so what that means, if I look at the VA or apparent power, I've got 15.3 watts or 15.3 VA. But if I look at watts, I've only got 9 watts, 9.1. So we'll go ahead and pop the brand new Walmart bulb back in. And I've got 15.4 watts and 15.4 VA. 15.4, 15.6. It's almost perfect. I'm very surprised to see a power factor of 0.98, 0.99. That is excellent on such a cheap LED lamp. Anyhow, I hope that answers a couple of questions on what was wrong with this thing that I did in the ASMR video. Everyone, thank you for watching. I really appreciate it. Have a great day. Bye-bye. And just a little addendum here, just in case anyone was interested. The current limiting or fuse resistor is 22 ohms on this unit. And let me drag out the ESR meter here. And we'll go ahead and make sure, yep, close enough, 0.1 ohms, we'll zero that out. And we'll go ahead and check the main filter cap on this unit. And I see 1.3 ohms of ESR on that capacitor. And so let me get a good zoomed in view here so you guys can see. A little too close. There we go. So that is a 250 volt 33 microfarad. But if you look very, very closely, let's just go ahead and stand it up. You can see that it is a 130 degrees Celsius rated cap. Whether I believe that or not, I'm not sure. LV, is that IBI or 1B1? Some kind of a code on the main board there. But 130 degrees Celsius rated cap. I find that hard to believe. Normally you only find those caps in some of the higher end automotive circuits. Okay, well, just a little addendum on the teardown of the 100 watt, 17.5 watt actual current Walmart LED lamp. Once again, thanks for watching. Everyone, have a great day. Bye-bye.